Hey, thank you, Nina. I'm glad to see everyone here. Um, Welcome to this breakfast seminar. Today we're going to talk about using SIEM systems for anomaly detection. And yeah, just to very briefly tell about the background on my slide is because of today, if you remember, if you know what I mean, what is the May 4th? Yeah, so it's May the 4th be with you, and on my background is the Armored Force of Ukraine. So let may the Armored Force of Ukraine be with you. And yeah, so I will switch to sharing my screen in a while, and we'll start with the brief overview again, back again to what anomaly is, and then we will go to the hands-on experience of finding anomalies and detecting them into our data flow. So let me share the screen. Yes, it's right here. Can you see it? Because it showed me different. Yeah. Okay. Cool.
This is visible.
Yeah. Thank you. So here's our today's topic is using SIEM for anomaly detection within the PROMIS project, and we're having these breakfast seminars as a normal practice PROMIS project. And few words about myself. I'm a senior lecturer here at BTH at the data department. I'm also an associate professor at Igor Sikorsky Kyiv Polytechnic Institute in Ukraine and Department of Cybersecurity. And I teach in several courses, and I'm also preparing and developing new ones within PROMIS. And those who are the courses that are already being delivered, they are machine learning and security, data-driven security, and introduction to secure software development. And some more courses are. So first, our agenda is going to be this. We'll consider the SIEM as a anomaly detection. But before, we have to start with defining what SIEM is. And for those who are not familiar with these systems, then we will try to understand which is the best. Well, not which is the best, but how to choose the right one for you specifically. Then we will unveil the magic of an SPL, which is for which is a specific language, like a query language within SIEM, specifically Splunk. And then we will proceed to actual example of anomaly detection using this SIEM system, Splunk. And then I will tell you a bit more about the upcoming PROMIS courses. So what is a SIEM? SIEM is a mix of security information management and security event management systems. And security information management SIEM retrieves and analyzes log data and generate reports. So technically, it's kind of an alert system. And then security event management is these systems, they carry out analysis of event and provide threat monitoring and incident response. So combining these two systems allow to create a new kind of system, which is a SIEM, security information and events management. And how to choose the right one? This is the very difficult question because there are multiple SIEMs on the market, not like thousands or hundreds, but still, it is very difficult to choose among them because they all have their pros and cons. And we will start with the main probably requirement for any system to protect is actually a price, because normally you use any cybersecurity tool, within your budget, and it's a matter of investments. So then the next one, the next requirement, which is not the least definitely is the functionality. So it depends on what kind of functionality is expected to be delivered, what kind of functionality is expected to be, to fit needs of your security officers. And then the next feature, the next requirement is actually flexibility and scalability. I put them separately, but it's more of about all the same. Flexibility and scalability. So how flexible this system is, and how adjustable it is, and how can you, easily connect it to other systems. And then scalability. Scalability is how quickly you can expand the system. So once your company is growing, once your security perimeter is expanding, how quick you can cover all the needs of the whole new big security perimeter. And then again, maintenance and support. Once your system is too functional, it's very heavy and very complex and very complicated. So that you have to understand which are you capable, I mean, in terms of your company, are you capable to maintain and support this system? And also on the other side of this issue is actually the maintenance and not the maintenance, but support from the company, from the vendor. So if vendor provides like instant support, etc., etc., and maybe some other requirements that can be very specific for this or that business. And I'm not going to tell you why. There's a lot of different researches on which SIEM is best or which is not, in different from different perspectives. But specifically to me, I've chosen Splunk as a SIEM that I deal with because of its high flexibility and high functionality. And probably in this video you will understand why. And it's not about comparison. I'm not saying that Splunk is the best. No, it's best for me. I love using Splunk. So within this lecture, within this breakfast seminar, we're going to dive deeper into what it is. So how normally, how normally we accept data and how do we process it? We first have to collect it from our security perimeter. We have to collect it from our devices or our software. And from this perspective, take a look at this very simple architecture. There is a search head that actually is kind of a control center that actually allows you to get an access to data and extract information out of data. So it's like that. Then indexer is something that stores your data and allows this access on a higher level. And then on the lowest level is actually the data input. So you can easily bring some static files or dynamic files or dynamic information, dynamic data flows to your indexers. And let's say from your network devices, etc., etc. But normally it doesn't look like this. Normally it doesn't look very simple. Normally it looks like this. So there is a search head, something like I told you, something like a control center, which takes the information and processes it from a different search peers, like indexes, right? So we may have a lot of different indexes which collect informations in many ways different from so-called forwarders. Forwarders are specific, I would say, software-specific application that goes within this Splunk. And it actually collects the information from different devices, from different types. As you can see on the slide, it can be different platforms, it can be different entities. And then it sends the information to search peers. And only after that, we are able to collect these kind of a more complex information from the search peers. But within these within this lecture, we're not going to use these kind of architecture because it's highly complex and complicated. Then what is what makes Splunk so beautiful to me personally? It's the existence of so-called SPL or search processing language. And SPL is designed by Splunk and comes with the Splunk software exclusively. And SPL encompasses all the search commands and their functions, arguments, and clauses. And its syntax was based on the Unix pipeline, and contains some kind of a SQL architecture as well. And it's app optimized for timestamp data. You will later see how it's being done normally. Well, SPL, and as we will see on the next slide, allows you to search, filter, modify, and in some way process the information, the data flows. And also, out of the box, SPL includes some machine learning and anomaly detection functionality. And also, as well, there's well-known separate tool known as machine learning toolkit, which can be applied, and we will see how to do that within this lesson. So technically, the SPL, the query itself, may normally have four kind of parts. So first part is a search and filter. So we have to have an access to some indexes of a different source types, and then we kind of play with the data. We can create a new variables that we can later use in a further work within the same SPL query or another ones. Then we can create some kind of reports. These reports can be static. These reports can be, like dynamic. And then we process the data, make the final processing. So we rename, we remove, we move, we do all these operations that will help us to actually get the final result. And here you can see the example of how search process language query looks like. It's not very complex, but still it's not very basic. Though, so we have to see that from the very beginning there is exactly search and filter part of this query. So we are mentioning the index, which we are taking information from. We're mentioning the source type. We can also mention the source itself, like the specific source, because one index as a kind of a logical data storage can contain a lot of different sources, and we can actually in this index we can choose different sources or source types. Then we can see that this blue squared, you see the eval stands for evaluate. So we're creating some kind of variables that like can be calculated or can be just announced and set into like 0 or something. Then we have this third type, which is report type. So here we have the command of a stream stats, and it actually allows us to calculate the median within the time frame of, as you can see, window 100. So it will take into consideration when calculating this median of a k value. It will take into consideration the past 100 points of data. And then the final is a cleanup. So we're building the actual table of what we're going to show on the visualization, what we're going to deal with. So this actually defines the final result of this search process language query. And now, as we will proceed with the SPL, you will see how to deal with it. But first, let's get back very briefly to what anomaly is. So what we're going to look for. And anomaly definition is that British dictionary says that it's a deviation from the normal or usual order type, etc., or some kind of irregularity. And we say that deviation from the normal or expected order is, I mean, the anomaly detection is a deviation from the normal or expected order type or behavior and irregularity of any kind. So why is it important? Because we can actually see a different anomaly types, but they are normally split into two big subdomains, large subdomains. One is anomaly of state, and another is anomaly of behavior. Uh, what makes them so different? Because anomaly of state is normally a reaction to external agents' behavior. And it can change over time. Maybe it can be a change over time, according to its internal issues of the system. And anomaly state is a type of static classification, and normally it has a kind of very strictly defined borders for values of which state is normal, which state is not normal. And instead, anomaly in behavior is a dynamic type of anomaly. It's an anomaly of activity, a deviation from expected, expected value, and no matter how big or how small it is. It can be big or small in both cases. It can be anomalous or not at the same time. Because if we expect some value to be high enough within specific circumstances, and it's low and within some kind of borders, so that we can define that anomaly is present still. But I'm pretty sure that you are aware of all these things, so let's keep going. Yeah, so well, if you remember our previous breakfast seminar session, I mentioned that the anomaly detection systems has to have some very specific features, and they are namely anomaly detection. Well, because it's important for an anomaly detection system to have an anomaly detection. Then it's real-time alerts. There is no matter of having anomaly detection system if you do not create alerts, if you do not alert user on some circumstances that have changed, or some specific behavior of your system, or etc. etc. And dashboards, it's very important to have a dashboard, because what normally security operation center specialist starts with is like taking a look at the dashboard. So once we didn't have any alerts during the night, which is good, then we in the very morning we come to our working place, and we look at the dashboards, and we can see what happened or what is happening right now, and it's much easier than to analyze the raw data. Then integration is definitely must have, and you will see why in this example. And because the integration, enlarges it, it makes your system more flexible. It makes your system more scalable. It allows actually to integrate your SIEM into, the big family of different security systems that protect your security perimeter. And so now it's time for demo, and I'm gonna start my new share. So, please confirm if you can see. There should be a screen with a Splunk. Yeah, can you see it?
Yes, yes.
Yeah. Okay, thanks. Yes, I can see it. Yeah. So here is what Splunk is. Let me probably show you from the very beginning, from the very scratch. So this is what you will this is what you will see when logged into the Splunk for the very first time. Well, not for the very first time, because we have this Splunk machine learning toolkit also already attached here. But what you normally do, you first you have if you're not familiar to Splunk and you're looking into finding a way to um, integrate this SIEM to your uh, security perimeter, you can go for it. You can find a lot of documentation now, and years ago, like maybe 8 years ago, when I started working with Splunk, it was very difficult to find some information about this because there was not very popular to have. There was not so many questions about Splunk, on a public forums, and there was also a lack of official information on the Splunk official website. And now it's fixed, and you can find a lot, like tons of information of how to work with Splunk, tons of video courses of how to actually make this SPL requests and how to extract data and how to make dashboards, how to visualize, how to send, and all the stuff that we're actually considering in our courses. And so the first, what you want to do when analyzing data is actually to add some data, right? So because if you have no data flow or data, you cannot do any things. And here you can see we can upload some information. Well, to perform some static analysis of maybe our log, maybe some other timestamp containing information. We can also monitor, as you can see, files and ports. So we can make Splunk. I apologize. Yeah, so we can make Splunk monitor our files and ports, so some specific files and ports, or even our system states, and then send it directly to indexes. And then the last but not the least option, which is probably the most used among all these three types, is forwarding. So like I told you before, we can set the forwarders to our devices, and then forward this information, some specific information of a specific device, forward it to the common index or to maybe its own index within Splunk. So what we're going to do now, we're going to select some file and let me, let it be this. And you see, the magic behind this is actually that Splunk has recognized that this is an access log. You see, it's an access combined. There can be also an access combined with cookies option, and you can actually create your own type of log if you have it. But Splunk actually contains, I would say, hundreds and hundreds of different types of logs that it can easily recognize. Yeah, and also you can then extract some data from it. So as you can see, as you will see, because it's on the next steps. Yeah, we can save it to existing indexes, or we can create a new index to keep this information separated from other logs, other data sources. Well, but let's do this. We'll put it into the main, or let's create a new index. Then review, it's good, and then submit. And then Splunk uploads this log into the index newly created. And then we can start searching, we can extract fields, we can add more data, or add more applications if we know that the existing application of a search head is not enough for processing this data, so we can add some more information. And we're going to do some of this. First, extract field. Okay. Because these logs are actually quite old, so it's very difficult to to fit into the time range of the last 90 days, because this is why it was empty. So now we change this time range to all time, and this actually means that Splunk gets the whole bunch of records for any log. And then we can start extracting information out of that. But if you don't mind, we should skip it probably, because I will have this information extracted, and I will show you another process how to do this, like as it goes on flight a little bit later. And then we have to also prepare, because we will need this machine learning toolkit. It is already installed into my system, yeah, but still, you will find this in on the application browser, application market here, which is built into the Splunk. And then, in my case, it shows Open App, but in your case, it's in the very beginning, it will show install. Then you press install, then you use the username and password, and then it's being downloaded and installed. So this is how easy it is, and then you have this newly installed application at yours, and then you can start searching. But to reduce the time of waiting, I have prepared some information. Yeah, if you don't mind, I will answer all the questions at the very end. Okay. Um, so yeah, so here how it looks like when you have downloaded, so sorry, uploaded the data to Splunk, and now we can start searching. So this is the very brief and basic request for based on SPL that actually allows you to get an access and to actually understand what data you have. And before doing anything, before processing this data, before applying any kind of machine learning or any other processing approaches, you have to understand your data. And if you remember, I was talking about this on the previous seminars. You have to understand your data. So first, what you have to do is to explore and to to play with the data, and how to actually get access to it within Splunk. So we have to mention source. So um, which specific file it is in. We have to mention index and a source type. If we do not, as you can see, it's 8,200 or something records. If we skip the source, we can find the whole bunch of data from index, which contains, in my case, three files, three different logs. So to be more specific, you have to be aware that you're dealing with with a very specific log if you need. So what can we see here? Here is the log. As you can see technically in any text editor, but it contains like more information about the specific features that have been extracted automatically. And we can see the client IP, we can find the information about the source type, user agent, and how many bytes also. And sorry. Yeah, and we can make some specific requests to this data. So let's say we're looking exclusively for an HTTP word or some other word, like what can it be, like fav icon, right? So we can perform all these requests according to what we are looking for. Also, let's say we're looking for HTTP requests and we can specify in brackets, we can specify that we're looking exclusively for HTTP OK response. And here it goes. You see, so we can see that the HTTP containing N200 response. Or it can be also a response of 404. Can we see here? Yes, we can see it here. Here it goes. So just for you to understand that the SPL supports logical operation. You can build very complex logical queries to get information that's specifically what you need. And then let's start with like a bit more complex things. Let's figure out how to visualize. And normally, if you have your data, let's get back here. So if you just press visualization here, it doesn't work. So despite you have a very specific request, you still have nothing to visualize. So before you start the visualization, we have to understand that, sorry about it. And we have to understand that actually any record in any log that Splunk can process has one very important thing, one very important feature. It's timestamp. So every single row, every single record should be timestamped. Well, it can be processed otherwise too, but it becomes much more difficult to play with data and to actually extract something of anomaly there. And I mean in behavior anomalies here. So and to have a visualization, to have it dynamically. We can use multiple approaches. One of those is actually to build a time chart, and this command actually allows Splunk to understand what kind of time chart we're going to build. And one axis, the x-axis, is actually always a timestamp. Well, not always, but if we do not mention anything else, it's a timestamp because it's a time chart. And then span, what means span? Yeah, but first, let's take this. So the y-axis is a count, in this case, count hosts as requests. So we are creating here a new value of requests, which is count hosts. Why count? Why not just host? Because host is normally it's an IP address, and it cannot be. It's not a numeric value, and time charts are normally for numeric values. And then we use this count function to calculate the amount of hosts of a different host, or maybe the same host, because there is also a different function of distinct count, DC, which we may use to calculate it distinctly, so like very on only different hosts. Yeah, but in this case, we count a number of hosts, count of hosts within span time. So in this case, span time is 1 second. And look at what we have here. So we just found this on this range, which was Wednesday, February 22, 2017, and yeah, a few hours of that day. So we can see a lot of requests, and in a way, it's good, and we can see that there are some anomalies, but they're not obvious. And if you can tell me why we cannot consider this 1 second time chart, to actually find an anomalies. Yeah, you mention it in the chat, please. Meanwhile, I will proceed. So, let's play with this span. Let's change it to, let's say, 5 seconds, and maybe after that you will find an answer to my previous question. Yeah, it has changed, not drastically, but it has slightly changed. Okay, let's move on. Let it be 10 seconds. Yeah, a little bit better, but again, not showing the whole picture. And then let's try 30 seconds. Yeah, and now it's much better. Now we can see that almost there is no, well, almost no zero values here. And if we add, oh, sorry, not 1 second, but 1 minute. If we add 1 minute here, so yeah, we will have this like more, more valuable, I would say, time chart here. But okay, now we understand how to actually create this time chart, how to look at it. And actually, yes, there's one more option here. You can change the view of this time chart. You can use the different types of time charts. Not all of them are available from the scratch. So for some of those, you have to prepare some data, prepare your output to be shown. Yeah, but for the very basics, it shows like from the scratch. Okay, so yeah, the reason why we're not going to deal with the 1 second span time chart is because its normal state actually about zero. If let's get back to 1 second just to take a look at it. You see, despite we can see a lot of peaks, we can see a lot of some kind of outliers here. They're actually not. Well, they actually are, because if we consider this time chart, we'll see that most of the time there is there are no requests. And so that if we are going to apply behavior analysis here, we'll understand that the normal behavior actually is having no requests. So that every single request is going to be an anomaly for this system. So this is why we do not want to deal with these types of charts. Okay. Now let's do a little bit more, and let's understand how to actually find anomalies in our time chart. So how do you think, is this an anomaly, or maybe is this an anomaly, like this very high peak, or maybe this is anomaly, or maybe this one is anomaly? So it's very difficult to understand whether something is anomaly or whether it's not, looking just at the chart. Yeah, sometimes we can see that if the value is very extremely high or extremely low, it can be an anomaly. But again, it depends on the system, of its behavior, of its type, if you will. Okay, let's go here. And yeah, before we start, we'll start doing it just one by one. Okay, so let's not do it by one. I will just explain the whole SPL. So what we have here, here we have a source from the index test. The source is access3 log. Then again, we chosen this time chart span 30 seconds. And if you remember what we were when we were talking about the anomaly behavior detection, so anomalous behavior, we said that anomalous behavior is actually a deviation from a normal behavior, right? So not normal, but from expected behavior. And how do we expect behavior? If we, have some kind of attraction, expected behavior is going to be the behavior that can be predicted. So if predicted value is not very far from its real value, so yeah, we can say so that we're, within our expectations range. And thus we have to use this predict function. Here it goes, predict request. So we are mentioning which field we are going to predict. And we then rename it to prediction, and we mention the algorithm of our prediction. It's in this case it's LP5, which combines different types. You can go to documentation to see how many different algorithms exist. There are not so many. Some of them include seasonal components, some of them not, but you can choose, you may choose whatever you need, again, based on exploration of your data. So the first step you cannot skip. Then we are creating a new value, the new variable, a residual, which is actually a deviation, right? So it's a prediction minus request. And then we provide this window-based, like a time frame-based new value of a median. So we're using the function of median of this new value residual and call it median. And then also we create a new variable of absolute deviation. So our median value of our residual should how it deviates from our median. So how our residual deviates from our median. So basically what we're doing here, and then on the next rows, we are creating this interval from a upper bound to lower bound, or vice versa, to actually understand which deviation is normal. And as you can see on the picture, as you can see, these bounds, lower and upper, they're changing over time. So it's like because of using this window, it's changing over time because it's like it's getting used to a new type of data that appears on a time series. So as we move, as we slide along the time series, you see this spread, this deviation differs, and thus this system is kind of getting used for a new type of data, for new values of data. And then finally, we create this value of is outlier. It's a logical value, but we made it not logical because to show it up exactly on the peaks of data. So if residual is less than lower bound, or residual is greater than upper bound, we have this value of residual. Otherwise, we have nothing. So we do not apply anything to this value. And then we are mentioning fields that we're gonna visualize, and them are always time, because it's a time-based. It's time chart, time series. It's a residual, and our lower bound, upper bound, and our value of outlier, and our request. So apologize. So let's proceed to the next step. And yeah, now we can see that we have found some anomalies, right? So we can see that some of them were actually shown here, some of them not. And this is not because miscalculations or something. This is only because these type of graph is actually not very precise, and it doesn't show it doesn't show precisely. Now, as we are not normally talking about some seasonal stuff, because when you deal with mm, yeah, but okay, let's assume we have this data taken from a very official website, and it actually could be. This is the time series of a login attempts for some system. I don't know whether it was a web-based system or some local. It doesn't matter here. So, but what we see here is that it has a seasonal component, right? So it has like 5 days of like higher activity and 2 days of lower activity. Then again, 5 days of higher activity and again 2 days of lower activity. And yeah, there is from the perspective of normal statistical analysis, every single peak is actually anomaly. But we have to understand whether it was expected or not, like in terms of our behavioral analysis definitions. And yeah, just to mention before we start moving forward, just to mention, as you can see, normally we had 5 days of activity and 2 days off. Yeah, and here we have only 3 days of activity and only 4 days of less activity or not activity at all. So now we're gonna move to a question: why did we actually install this Splunk machine learning toolkit? And just take a final glance at what we had here as a very complex request, SPL request. And yeah, and this actually is kind of what we have with a very simple request of input lookup log and CSV. And then using this Splunk machine learning toolkit, we can do the following. So we can, again, predict logins, naming it prediction, with an algorithm of an LLP. And LLP is the prediction algorithm that actually includes the signal component and the future time span 150. So we will make a prediction for 150 points. And yeah, we don't want to have the predictions and logins like actually we don't have to deal with zeros. And then we evaluate these residuals, which are predictions minus logins. And then we have to execute this. And now what can we see? We can see this newly created graph, and it actually contains, you see the orange one is actually our residuals. And it's kind of a very difficult to understand how big it is. As for now, we'll understand why and how to make them more convenient. Here is our initial time series, and then yeah, here it goes. The prediction. You see, the prediction has its own lower and upper bounds, and it's kind of a confidence interval. So we're predicting in this confidence interval, which is normally and by default is like 95% confidence. Yeah, but let's add some magic here. Now, as we have these residuals, as we have these prediction functions, as we have these outliers actually, so we can just technically put this. Not yet, sorry, not yet. Not yet. We'll get back to it. Yeah. So now, to understand how this actually works with the machine learning toolkit, you may go to as you go to. Let me show you this. As you go to Splunk Machine Learning Toolkit on the very first page, on the home page, you can see this all the applications you have. Normally, it's like several screens. Then you go to Splunk Machine Learning Toolkit, and at the top you can see this menu containing the showcase section, experiment section, search section. In experiments, you may create some different experiments, and we'll consider how to do that. Search models and schedule trainings and alerts. and some settings. And just to quickly mention that, here you have lots of different modules that are kind of built in here, so that you can make some adjustments to the numbers. You see, so there are default values for let's say DBS scan algorithm, but you can adjust it. You can do whatever you want with this data. Here we're changing this can drastically change your output. Yeah, I apologize. I have to connect my laptop. It's draining off. 1 second, please. Yes, sir. Now I'm back. So to play with this, to understand how it should be done, you can go to detect outliers, or not by ML operation, but you can go by industry and choose the industry which is like yours, and then you will have the same examples, but just combined into a different way. So we can detect outliers. So we can actually do exactly the same. And you see that it shows you the same example. And just, yeah, here it goes. So now it doesn't show anything, right? So we have just a search, and this is how it looks like. First, we are performing a search. Then this search actually gives us some kind of a raw data, and here it goes, the raw data preview, we have it here. And then we have to make this machine learning magic. So even if you are not familiar with any any machine learning tools, and you do not understand what machine learning does, well, it is much better for you to understand what it is. But even if you do not understand, you may choose, let's say in this very specific example, you can choose residuals, because, residuals, because what we're looking for is the residual that actually goes out of boundaries, out of, you know, possible normal behavior, right? And then you have to choose the threshold method, and normally, well, the standard deviation doesn't give a result in this particular case, and as well as interquartile range. And we use this median absolute deviation because we are interested in deviations from to both up and down. And also there is a threshold multiplier, because if you choose nothing, or you're not going to multiply anything, you will have so low values of this threshold, so that every single step is going to be an anomaly. So you have to perform your own analysis on this step. And then again, sliding window, if like I mentioned before, it's the window that we take into consideration when calculating this median. When calculating this median. And now, then this is what happens. We press detect outliers, and the whole machine learning process has been done, and the values have been obtained. And now what we can see here is actually the um, deviation. As you can see, this blue line is a deviation chart. And this blue area is actually, this lower and upper bounds. And now we can see all these outliers. Well, we can actually skip these outliers, because on the very beginning it was like 100. How many was that? Should be it should be 72. Yeah, before it's 72 values on this range. That was the range when we had no predictions, and we had no this interval, we had no lower and upper bounds, and thus we can skip it, because if we overlay initial logins chart here, so we can understand that there were no anomalies here. There was just a very beginning, and then we can see that some of these values are actual anomalous, and we could not consider these, let's say, or this value to be anomalous because it is within the range. And we would say, or we would think that, yeah, they're normal. They're actually not. Yes, there are some obvious outliers like these, or this, but there's also multiple outliers that cannot be expected, so and cannot be predicted, and they're out of this boundary. Well, oh my God, I'm talking about 1 hour. Yeah, so I'm about to finish. Yeah, so now, to find it, to detect an anomaly is not the, thing itself. The reason why we're doing this, because we want to have the information about anomalies, and thus we have to uh, put it on dashboards, as have been mentioned on the previous slides of the presentation, or and we have to schedule an alerts. And this is how it's very quick to do from this place. You see the search is already mentioned here, so you don't have to do this by your own. Well, test alert, let it be this, no description. Yeah, number of outliers. So once we have the outlier appeared, so just one. So once we have the outlier is greater than 0, we have to make some kind of action, perform some kind of action. And what kind of actions can we actually perform here? So here's the trigger actions that we can do. Add to triggered alerts, and this is to build like more, I would say, more complex alerts. So let's say if we have this condition executed, let's say yes, another one and third one, and only after that, only with combination of 3 different alerts, we are creating and we're sending some kind of a major alert to security officer. We can log this event. We can we can make an output to any system. But the most interesting part here is that first we can send an email. Yeah, it will also require from you, from the admin of this system, to set up your own mail server, but still we can send mails, and actually including the source string, the trigger condition, the trigger time, and also attach the CSV file with the specific part of the input value, or even attach a PDF with the reports. Then also, what we can do more, we can, use the webhooks. So if there is something that exists by a specific URL, that some kind of a script, like outside script, that can take this information and process it, and then do some actions that you require, it also can be done. But the main part of it is actually that you can run your own script. So you can, this is what is called like flexibility. This is what is called integration, which was mentioned on the slides before. So you can run your own script to do something, and this something depends on what are your requirements for the system. If you want the system to be just an ideas, right? So you can just detect anomalies, and then inform admins that something is happening. Yeah, this can be just an alert system, or you may convert the system into an like intrusion prevention system to make something to prevent to counteract activities of a potential malicious user. Or you can send it to Splunk Mobile, to send the information like in a very like instant manner. Yeah, this is what we can do, but we have no time to adjust all these settings. But also, what we can do here is Yeah, we can. Yeah, you can also create an alerts from here. You can create reports. You can create alerts, and we can add it to this board. Let it be again test. It's going to be classic dashboard. Yeah, and we save it to dashboard. What? Yeah, yeah. It was. Yeah, so now we can see this dashboard, you see, and this is what you start your normal security day with. You come to your CM system, you know, make some coffee, and then you just look at, you observe what has happened when you was away or what is happening right now. So these kind of dashboards, they can be real time, they can be like, you know, very informative. They should be very informative, actually. So yeah, I apologize for this took so much time. Well, my intention was actually to explain it in half an hour or something. Yeah, so now I'm ready to answer your questions, and I can see some of them. Yeah, which input sources Splunk can digest? Well, actually, any type of source. Actually, any type of source. So it can be something informative, so something that can be logged, and you know, most of it has contained a timestamp. Well, it's not like absolutely necessary. There are some ways to, you know, to overtake this issue, but there is no necessity to add something that doesn't have a timestamp, because, you know, CM system is actually built for timestamped logs. Yeah, and the previous graphs seeing increased traffic after AM seems to be normal in humans perspective. It was probably something like that. Yeah, there was this graphic. Yes, exactly, exactly. And this is why it's very difficult to understand, even from humans perspective, it's very difficult to understand whether it's like legitimate or there is some kind of anomaly here, or maybe some kind of malicious activity. And also, increasing is not always malicious activities signature, because you know, when it is expected to get, you know, to grow, and you then, instead of growing, you have like this very low value. Yeah, this might be a problem, actually. And there is also, for login activity, I believe comparing successful login attempts and failed login attempts might be interesting. Yes, exactly, exactly. Thank you. And this is a good point. The reason why I was telling you about the very first step, you have to explore the data, and then you can understand how to play with it, how to create some kind of, you know, sort of um, new features, like if you have something like number of requests, then you can create a new feature, number of requests per time, or you have a feature of bytes sent, right? Then you can create the bytes sent over the requests from this IP address. So you can have you can play with data, and you have to play with data, and you have to extract as much information out of your data as you can, as it's possible. Well, and now I'm going to show you a few minutes. I'm going to show you our upcoming courses that we're going to start delivering in this autumn. And these are development security application, DevSecOps. It's 7.5 credits. These are security inventory for software development, applied cryptography, security for critical infrastructure, and web system security. Well, despite the web system security is kind of probably one of the most dependable, they're most popular. I would say that it depends on your area of interest. It depends on your business you're involved in. Um, I encourage you to apply for those courses that are that meet your criteria for doing your job more effectively, probably. And you should be aware that these courses are designed specifically for professionals, so there will be no extra stress for you because it's given online. It's quite flexible, and specifically, it's applied on 20. It's like 1/4 study pace, 25%. So it's not like a regular like master's or bachelor's course. So you will have your time to complete all the assignments. There are not that much assignments on every single course. Yeah, and these courses are free of charge. They are university credits, and you can even like technically you can build your own master's having all these credits. If you have enough credits, you can also even obtain your master's diploma. It will take some time, probably. Yeah, if you have any questions about applications, you can contact our coordinators, our magicians, Nina and Anna. Uh, yeah, I encourage you to apply right now, starting from now. And I will be glad to see you on our courses.